Hi everyone, welcome to another bioinformatics tutorial session. In today's tutorial, I am going to show you how to count variants. So this is what we are going to do. Let me open the output first. That's what we are going to generate by the end of this tutorial. I have it here. So this is what we are going to do. We are going to use some bash scripts to count the number of variants per chromosome per sample. All right. So if let's say you perform your variant calling and you are dealing with multiple samples, then you can represent your results in this form. Okay, so this one I call it a summary, and this can help you to easily compare the samples and even the chromosomes. So if you count the number of variants, you can put this in this table like this, where you have the chromosomes, you also have the samples, and you can look at the number of variants for each chromosome in each sample like this. So if you take a look at this table, this is the chromosome list. Let's say chromosome 1. In this sample, all right, 322 variants were found on chromosome 1. In this sample, it was 434. When it comes to chromosome 2, in this sample here is 385, etc. All right. So if you represent your results like this, it's very easy to understand and explain. All right. So I call this a summary. This can give you an overview of what happened, and you can also use these tables to compare the samples. You can compare the result for the samples. You can compare the results among the samples and even among the chromosomes. All right, and also chromosomes and samples. I mean, so once you have it this way, it becomes easy. That's what I was saying. It becomes easy to explain your outputs. It becomes easy to present them, because with genomic data, you can have lots of information. So it's important that you put your results in a way that can be easily explained and presented. So this is one such example. All right. So this is what we are going to do. So if you have your VCFs, after you have generated your variant, after you have performed your variant call, you have your data. There are two situations you will encounter if you want to generate a table like this. And we are going to look at all those situations, the two of them. So let's take a look at the two. So one scenario will be that you have your results here. Let me just show it. I think I'll start with this one here. We can have this situation. So we can have a situation like this, where you have your variants, everything in a single file like this. So this one is a multi-sample VCF. So that means that all the samples, all right, they are in a single VCF file. All right. So you will have to write some bash scripts to extract the information, the chromosomes, as well as the samples, and then get the counts, and then generate the table that I showed. Another situation or another scenario is that you can have the variant identified for each sample in a separate file, like this one here. Okay, so here we have 10 files. Each of these files represents a sample. So the variant for sample P800070 is in this file. Okay, the same applies to this other one. So these are the two situations you will encounter if you are going to count your variants and generate the table that I showed. So I'm going to take you through all these scenarios. Okay, I've already prepared the bash scripts, and I'll also explain how you can use the script here on your own data sets. So that's what we are going to do in this tutorial. So in this tutorial, what you need to do is to make sure that you have installed BCFTOOLs. That's what we are going to use. That's the main tool that we are going to use. So instructions for installed VCFs can be found in the description box. So make sure to install that. In addition, download the example data and then the script. So everything here, the links are in the description box. If you are watching from Patreon, then the files here, the materials here are attached. So they are attached as a zip file. So just download the zip file, then you can proceed. So when you download the zip file, this is what you are going to get. So you are going to get something like this, and then you have to extract the content and then proceed. Right. So that's what we are going to do next. So once we download it, open your terminal and then start the exercise. So let's start. So I'll open my terminal now and then start. You should also take note of the directory where you are working. It's important. If you are working on a cluster, still make sure to take note of your working directory. Right. So I'm going to open the terminal and then start. So because I'm using an Ubuntu system, I can just right click and then just go to open terminal. But if you're working on a cluster, then you just have to log in straight and then you have access to your terminal. So on the terminal, I also want to make sure that the zip file is in my current working directory. Right? So I'll first do an ls to make sure that the script is here, not the script, the materials are here because this is a zip file. All right. On the terminal, I'll make sure that the materials which have been zipped is in my current working directory. All right. If I do a pwd2, I also know my current working directory, and this is where the zip file is. So what I have to do next is to unzip the file, unzip it. All right. So if I unzip, that means I'm extracting the contents. That's what I need to do. So I'll say unzip variance counter, etc. So there's it. And then I will extract everything. Right. So let's do this. Let's clear the screen. And so this is what you are going to get. You have your scripts and you're also going to have some directories and then text file. All right. So we are going to proceed. So this is what we are going to do. I'm going to start with the first scenario. That is the multi-sample VCF. All right, that is here. So let me do an ls to see the multi-sample file, the multi-sample VCF. So this has everything we need. All right. Now I've already prepared the script that we are going to use. So I will open the script for this scenario here and I will explain a couple of things and then we run it. All right. So for this one, we are going to use this one, variance counter chrome sample multi-sample. Okay, multisample.sh. And then we run it. Okay. So with that for the first scenario, all right, where we have a multi-sample VCF file. Okay, so let me do a cut and then display that script. All right. So the script here, this is it. So for the script, the only requirement is to supply the script with the VCF file, which has the information that we are going to extract. All right. So in this situation, in our case, it's multisample.vcf.gz. Okay. So this file here can be found in the directory multisample VCF. So we need to specify the path. Okay. So we will need to edit the script. I will open another tab here and do an ls. All right. So we are going to edit it because I also want to show you how to use the scripts on your own data sets. So I will use nano variance counter sample underscore multisample.sh. Then I'm going to do this. I'm going to come to this side VCF here. So here you see a double quote here. All right, so what I want you to do is to keep the double quotes, but then in it, I want you to put this. Or if you are not sure, if you are not comfortable, just clear it like this, and then we can still do the entry. All right, so for now, let's just clear it. Let's do it this way. Okay. So we have opened our scripts like this. And so what we need to do next is to supply the script with our VCF file, right? I'm going to do something like this. I'm going to do this. So what we need to do is to supply our script with the VCF file, which has the information we are going to extract. Okay, so where is this file located? I've already explained it. I'll just go over. So let me do an ls again. Let's do this. So the VCF file can be found in this directory. So what I need to do is to supply the path. So the path is going to be multi-sample VCF. I'll put this in double quote by the way. So I say multi-sample VCF slash, and then I indicate the VCF file itself, which is here. Like this, and then I'll bring my double quotes. So this is the path to the VCF file. That's the only requirement you need. All right, all the heavy lifting will be done automatically for you. All right, so the script starts with indexing the VCF file, and then it also gets all the samples from the VCF file, and then it also gets all the chromosomes. All right, and then it does everything for you. Now, if you're an advanced Linux user, you can also specify your own chromosomes. If, let's say, you have some chromosomes of interest, you can put them in a text file and then also use that. I think I'll cover that in the next activity that we'll do. So, but for now, this script has been designed in such a way that all the chromosomes in the VCF file, you have the count for them. All right, so that's what we need to do. But if you want some additional modification, just let me know, then we can work something out. You can also book a session. All right. Now, for those who also want to give a tip as thanks for this tutorial, you can also do that in proportion to what you have gained from this tutorial. Now, let's proceed. So let's do this. So let's continue. So after getting your samples and chromosomes, then the processing starts, and then you get this output. This is the final output you get, which has the information. All right. So let's execute the script. I'll press Ctrl S and then I'll save the changes. All right. Now we need to execute the script, but before we do that, I'll need to add execution rights. So what I'll do is to say chmod +x. Now specify the script, this one here. I'll do an ls, and then depend on the system you are using, you will see that the color of that script has changed. Now it's executed, but if you don't see any color, that's also fine. So far as this command was executed and there was no output, everything is fine. Okay. Now what we need to do is to execute the script. So I'll say // now call the script like this. So let's execute it. Perfect. So once you start executing, here's what you are going to see. You're going to see the header coming up, just an information. Then you will see the list of chromosomes being processed or being counted. Okay, so now everything is done. So let's clear the screen. If you do an ls, you are going to find this output, which is chromecount.csv. Right? So this has the information. Okay, you can do a cat chromecounts.csv and you see this. But the way it is, it's better to rather open it in a spreadsheet software, right? Okay, so that's what we are going to do. We are going to open it with the spreadsheet software and then confirm what we have. Okay, so I'll open it now. Okay, so this is it, right? So this is the final output that you have. Okay, so that's it. So this is for the first scenario. Okay, so if you have it like this, then you can also proceed to generate a heat map, or you can also generate a bar graph or bar chart or any other visualization that you see or you deem appropriate. But that one, it depends on you, and it should be done on case by case. Okay, it should be done case by case. All right. So that one, I'll leave it to you. But if you want some additional visualizations, you can always reach out to me and you can work something like that. But what we have here is very simple. And so when you have it like this, it becomes easy to interpret, it becomes easy to explain, it becomes easy to present, because now everything has been simplified for you like this. You can also compare the samples to each other, chromosomes to each other, and stuff like that. But everything here looks cool. Okay, so that's it for the first approach. Okay, now let's take a look at the second approach. So I'll go back to the terminal. I think I'll close these ones. I don't need them yet. I'll close this one. Okay. Now you'll notice the first script that we use, there's the name, chromecount.csv. So the second script that we are going to use, that's the second approach. The output is slightly different, but just for you to compare them. But anyway, once we execute the script, you know what I'm talking about. So let's get back to the terminal. Okay, now let's take a look at the second scenario. So in the second scenario, we are going to use multiple VCFs. All right, so ls into the directory VCFs. So ls VCFs, I'm going to find some VCF files here. I think I'll also open it here like this. So we have the VCF files here. So each VCF file represents a single sample. All right. So here, the script that we are going to use, you need to add more information. Okay, more commands to it because we have the samples in separate files. All right. So we'll have to write a script that will get the counts in this file, this file, this file, all these files, and then aggregate them together for us. And so with the second approach, what I recommend is that you have your chromosome list in a separate text file, in a separate file. So that's what I have here. So in the second approach, you will run the script, this one here, but then we need to supply some information, including the chromosome list. Okay. Anyway, let's go back to the terminal. Let me display the script content, and then we can talk more about it. So I'll do this. Let me do an ls first. Let's say cat. I'll supply the file name like this. That's this one here. Now display it. Okay. So I have the scripts displayed here for me. Okay, so that's it. All right. So this script requires some information. You need to supply it with the directory which has the VCFs. You need to supply it with the text file which has the chromosome list, the chromosomes of interest, and you also need to supply the file extension. I'll explain everything very soon. So I want us to open the scripts and then edit it, and I'll use that to explain some stuff. So I'll say nano. I'm using a different tab. This is different from this, by the way. So just take note. So you can use any text editor of your choice, that's fine, but I prefer to use nano. So I'll open that. And then I'll come back here. Yeah, let me start from here. So first of all, we need to supply that script with the directory of the VCFs. All right. So you can see that the VCFs are here. Let's clear the screen. Let's do an ls into VCFs. You see them here. Let's do an ls. So there's the VCFs directory. That's it. So I need to supply it here. So I'll bring my double quotes and I'll say VCFs like this. Now you will notice that if I do a pwd, the working directory is this. All right. But here I just place VCFs because I'm working the same directory as I'm working the same directory which has the script, the bash script as well as the directory. Right? So that's why I just use VCF. But if your VCFs are in a directory which is outside the current working directory, you have to specify the path, the correct path. So you take note of that. Or to be on the safer side, you can move your VCFs into the directory which has the scripts, and then you can just specify their names. That's fine. Okay. Now we need to supply the text file which has the chromosome list, and that is here. Chromolist.txt is here, right? So first of all, let's display the chrome list.txt. Let's display. So these are the chromosomes. All right. Okay. So let's do this. So I would also like you to look at this. I want you to do this. Even though we have the chromosome list here, I want you to also do some additional checks. So the most important thing here is that the chromosome list you use should be the same. The name should be the same as what is present in your VCFs, in your VCF files. All right. So this is what we are going to display the chromosomes in one of the VCF files and assume that the others are okay. If we just want to compare. So I'll use BCF. So I'll say BCFTOOLS query-f. I bring a quote, I'll bring percentage, I'll say chrome/n. Okay, and then I'll supply one of the VCF files. I'll bring a pipe and I'll say unique. I'll execute this command. Nice. So now you see that there's the list that came up and it's the same as what is here. Okay, so we need to make sure that they are the same so that BCFTOOLS can do its work proper. Okay. So now we know it, so we can supply it. So another double quote, I'll say chrome list.txt. Let's confirm to make sure that the names are the same. Okay, so we have that here. All right. Now let's do this. Let's add a third one, which is extension. So what is extension? Let's do an ls into the VCFs directory again. So the extensions, or let me say a file extension is the letters or the characters that are at the end of the file names. So here the .gz is an extension. We can also say .bcf.gz is an extension. I repeat, here .gz is an extension. We can also say .vcf.gz is an extension, right? But to put the right extension in the bash script, we need to consider this. We need to add an extension or the characters that when you subtract from the sample name, you will be left with just the sample name. Right? So this is the sample name or sample ID, if you call it that way. So if we subtract this .vcf.gz, we are going to get just this one here. So that means that the extension we have to is .vcf.gz. So some of you may not have .gz, some of you may use just .vcf, which is fine. So if it's .vcf, you place .vcf in the script. But for this tutorial, for the materials we are using, the data set we are using, it's .vcf.gz. You should also make sure that all the VCFs we are dealing with have the same extension, the same file extension. So you will notice all of them, the extension is .vcf.gz. It should be uniform. All right. So let's place it here. I'll bring my double quote and say .vcf.gz. All right, like this. So that's it. The rest have been taken care of automatically. All the heavy lifting has been taken care of. Okay, so that's it. So we are going to generate this file. This one here, chrome count.csv. Okay. The first scenario we use chrome counts. There was S. This one there's no S. It's just to differentiate between the output so that we can compare and make sure that we have the same results. Okay, so that's it. So if you want a detailed explanation of the scripts, you can always reach out to me. And there's something that I need to bring to your attention. It's very important. I should have done that in the first scenario, but I have to do it here. So if you take a look at the command I'm using to extract the variant and counting, I have this -C1. The -C1 here allows us to extract the true variant. All right, it allows us to extract information for the true variant. Right. So if you perform your variant calling, you have the true variants. You also have those that are false. Okay, so the C1 will help you to identify the correct variant or the true variant. Let me just switch it that way. And then I also encourage you to do this. After running the script, I will encourage you to also compare the result you have to the result that you get from using other tools, and then see if the results are consistent. Okay, so it's advisable to do that, and then just make sure that everything is okay. So with the counting of the variants, you can even use some ordinary bash scripts, but that one may not give you the appropriate results unless you add some additional information. So this one is much simpler to use, right? So just make sure to do that. So you can also try with GATK. GATK also has command that you can use to extract variants, true variants. So you can do that and compare the results, and then get me a feedback. I'll appreciate it if you can do that for me, right? But I've been using this command for a long time, so everything is okay. Okay, so that's it. So let's edit and save changes. So again, I will add execution as I say chmod +x. I will specify the file name here. All right, that's done. So now I am going to execute the command. So I'll use // I'll call it like this. But you can also say bash, then apply it with the file name. That's also fine. But I will use the other approach. This, and I'll execute it. So let's execute this command. All right, so it's been done. So it starts with indexing the VCFs, and then it starts counting the variant for the chromosome. So we have it done. All right, so let's clear the screen. Let's do an ls, and we are going to find the output here, which is this one here. So I will say cat home count.csv, and I'll have that also here. So you can also open that. Let's do that. This is it. We can open it and then get our hits. So this is it. All right. Let me open the other one so that we can compare. And then you see that we have the same output. I'll just compare chromosome 1 to this sample. So that is here. So 322, 322, that's fine. Okay, so that's it. So yeah, this is for the second scenario. So that's it. I'll close this. Then we just have this. Okay, so this is the output for the second scenario. So that's how we do it. So in a nutshell, we have been able to generate a summary for variant that we identified. Okay, so this is actually a good news. Now, let me also say that the data set I'm using is a data set that I obtained from the malaria gene database. So these are variants that were identified from Plasmodium isolates. All right. So if you want to learn how to also call variants, there are tutorials that you can use. So you can check the description box for those tutorials as well. So that's all for this tutorial, and I'll see you in the next session.